My last example is actually a very nice example, I think, that really illustrates the idea of there's surface semantics and deeper semantics, and relating these two sometimes can be done and sometimes not, but how it's really the science is in studying those two and the relationship between them. And this is work by two people, Renfro and Gosling, relating to the relationship between one's music library composition and some psychological characteristics. You could obviously see the interest of this to us, and I can imagine to some of you there, this work also could have some interest both for the method and even the actual results it suggests. What they did is they looked at people's music libraries and they did a factor analysis. So they tried to impute that there must be some hidden factor or some set of causes that determine what kind of music library you will have, the composition of your music library. They also then administered to one test group some psychological instruments, and in part of their work they tried to similarly decide if they could at least categorize any portion of the psychological attributes that they measured into categories. And then they tried to establish, based on looking at this is your music library composition, this is your psychological profile, is there statistically significant correlations? And in fact, they found some. So that was the first part of the work. The second part of the work was knowing that, and this was the second paper, they actually presented to a second test group just information about the music library to see what people would impute about the psychological characteristics of the library's owners. And again, they found in some cases that the second test group could, to a statistically significant level, predict just from the music library certain psychological character attributes that were derived from these psychological instruments. So there's a nice example. They had a hypothesis that there should be a correlation. They derived a model. In this case, they said there should be 4 factors that were psychological factors. They did the work of actually collecting the data, doing the model, the statistical analysis to prove or disprove the model, not to give them the model. And in the end, they came up with a nice example of how the music library were observable proxy semantics for the real semantics of interest. I think is what this illustrates is science is required to confirm the proxy semantics were valid. And I think this seems to me is a very interesting general problem for technology enhanced learning. I think this almost seems to me there could be a whole class of research studying this that, again, it may already exist, and hopefully you can tell us if it does, because we would really like to find that material and study it a little further. Maybe I can conclude and pull all this together and say what we see the challenges are for social recommender technology-based social information recommendation applications to technology-enhanced learning. The first is that the recommendation technologies themselves are fairly simple. The key is that domain knowledge to drive them probably is going to be a bigger challenge in applications to technology-enhanced learning than it has been to media item recommendations so far. Such a big challenge that, in fact, I think we should think of them as almost an evolutionary step in the development of social recommender technology, and a very interesting one. The reason is, as I've tried to outline here, the applications may require much more sophisticated approaches to deriving information from the data. In particular, as we pointed out here, the superficial statistical semantics that have worked well for recommending consumer products, there seems to be good reason to think they could be inadequate for learning materials. One thing in particular, that because the technologies, the recommendation technologies are out there, the methods for getting data are sort of canned, and analyzing data is sort of canned at this point, I really do think one of the best things we can communicate is to be careful not to unduly shape the recommendation model to the data available, or inappropriately substitute data analysis for doing the science. I think really the interesting thing, and I'm actually kind of interested in the whole domain area you're in, I really think there are some interesting scientific questions there, and sort of the gravy for the science will be actually how the results can be applied to social recommendation technology. And so if we approach it that way, we'll get some very interesting advances. And maybe as one example, I can illustrate, or one particular area where I think this is going to be particularly relevant, is that if you think about it, many of our current recommender apps really require only simple concepts of how user tastes over time. We're talking about maybe music taste, how they evolve over a few years, but people's music tastes actually don't change that much from what they were as young adults usually. Product purchases and product recommendations are also a very limited aspect of our daily life and our psychology. So again, I'm not sure that the how user tastes change over time are so significant or so complex at that point. Learning, on the other hand, really is all about how a person grows over time, and we know that's a very complex, very involved, and lifelong process. So I just think this idea of how what we would need to recommend changes over time as we develop ourselves cognitively is just a really exciting problem to look at. And I think you people are really situated in a very interesting juncture there. And I think in the long term, we hope to be looking to your results to help us a lot more than I suspect you'll be looking at our results to help you. So I thank you for the opportunity to present this, and I guess maybe we're going to have a chance to take a few questions. Thank you.